Hey everyone, welcome back to my channel. In this video, we will learn about dependency injection using Dagger-Hilt. The topic is kind of tricky, but don't worry, I'll try to make it as simple as I can. Also, dependency injection is a very vast topic, so one video is not enough for it. Hence, in this video, I'll only cover the basics of it. Later, in some other video, we will go in detail about it, okay? Now let's understand what exactly dependency injection is. So consider a code where we have multiple classes dependent on one class, which makes the entire code tightly coupled. Tightly coupled means classes are dependent on each other, and ultimately it becomes very difficult to manage and test. Hence, to overcome this issue, dependency injection was introduced. As the definition says, that allows the separation of object creation from their usage by making code more modular and testable. Means it makes the entire project loosely coupled and removes the dependency from the code. Also, as the last line says, by providing required dependency to classes from external sources rather than having to create their own. Here, external sources means using Dagger. Next, this is a general diagram where we have class A and class B. Here, class A depends on class B, which makes the class B as dependent of class A. Okay? As I previously said, there will be multiple classes depending on one class. Here for the general example, I have only one class depending on another class, but there could be multiple classes like class B, class C, class D depending on class A. Got it? Now next, in dependency injection, we have two types. Manual dependency injection, DI means dependency injection, okay? And automatic DI. Let's have a detailed look at them. So in manual DI, we create the object manually without using any external resource. Although it is not recommended to use manual DI because we have a better and advanced option available, that is automatic DI, which we will see in upcoming slides. But first, let's see what are the types of manual DI. We have two types in it, constructor injection and field injection. So in constructor injection, we pass the dependency of a class to its constructor. Simple. Then in field injection, dependencies are instantiated after the class is created. We will cover both of them practically as well, so wait for it. But for now, let's have a look at automatic DI. So in automatic dependency injection, we have two types, Dagger and Hilt. Basically, in automatic, we don't have to create each object for every class. Instead, Dagger or Hilt will make it for us. And that's what automatic means, right? Hence, it is highly recommended to use. Now let's have a look at each one of them in detail. So first, what exactly is Dagger? I kept the definition very simple to understand. So it says, manual dependency injection can be problematic depending on the size of your project, obviously. See, means having 3 to 5 classes depending on one class, that is fine to handle, right? But there will be project where we will have 100 of classes depending on one class. Now that is difficult to handle, right? And that's when Dagger comes into the picture. So basically, Dagger generates the same code what we would have manually written. But here comes the twist, that it internally creates a graph of objects that it can refer to provide an instance of a class. Basically, it generates a factory type class that I'll show you when we will create the example project, okay? Now, all of this is done using annotations. Let's have a look at them. Module is used on a class that construct object and provide dependencies. Provides is used on a method in the module class that will return the object. Inject is used on field, constructor or method to indicate that dependency are requested. Component is used on a component interface which acts as a bridge between module and inject. Singleton is used to indicate only a single instance of dependency object is created. And that's it. Then next is Hilt. Again, it makes the manual dependency injection easy to use by reducing boilerplate code. Basically, Hilt provides container for every class and manages their lifecycle automatically. So we usually use Dagger and Hilt together, but for now, not to make the project very complicated, I'll be using Dagger only. But later in upcoming video, we will cover Hilt as well. Now let's have a look at an example project. So this is what a project representation looks like. We have one class C and two classes, that is class A and class B. So class C depends on class A and class B, which makes them dependent of class C. Basically, every time we want to access class A and class B, we need to create an instance of class A and B in class C. That makes it tightly coupled, right? Hence, we will be using Dagger to remove the dependency. I have divided the project in 4 cases. In first case, we will write the code without any use of dependency injection. Then in second case, we will write the code using manual field injection. Then in the third case, we will write the code using manual constructor injection. And then in the fourth case, we will write the code using Dagger. Got it? Let's go to Android Studio and create it. So first, let me quickly create the 3 classes. That is class A, class B, and class C. And done. Now, in class A, it's an example project, so I'll be simply printing a line in logcat. Nothing complicated, right? So here first, I'll create a function named as start class A. And inside it, log as tag and message as class A started. And that's it. Similarly, I'll do it in class B as well. Function start class B, and inside it log as tag and message as class B started. And that's it. As I previously said, class A and class B are dependent of class C. So go to class C, and this is where we will create an instance of both of them. First case, without using dependency injection. So inside class C, I'll call class A and class B. And done. Then we will create a function as start class C, and inside it I'll create an instance of class A dot start class method and class B dot start class B method. Then write a log for class C started. And that's it. See, class A is independent, class B is independent, but class C depends on class A and B, right? Then lastly, call class C in main. So go to main activity. I will here call class C. Then create an instance of it as class C dot start class C, and that's it. This is what the code looks like without dependency injection. I know you will be wondering, it looks so easy, nothing complicated, but think as a professional developer. Then you will realize this is all tightly coupled, which makes your code very difficult to manage and test. Probably not in this case because there is only 3 classes, but imagine a project with 100 or even thousands of classes. That's where all these advanced topics are used. I'll show you the output. See, in logcat, we have tag as class A started, class B started, and class C started. That is very basic. I'm not going to show output in every case because it literally is same. What important is our code because that is different in every case. Now let's move to a second case using manual field injection. Class A and class B will be as it is. Only class C and main will change. So let me quickly comment all the previous code. And done. Now see here, as the field injection says, dependency are instantiated after the class is created. Hence, instead of making instances private, here I'll be using late in it. So let me quickly write it. and done. Late init modifier declares a property without initializing them immediately. And we will initialize them, but not here in main. Okay? And that's what field is, right? Then where means the value can change later. And then similarly from the previous code, we will write start class C function as it is. And done. Then go to main activity. Here I'll call class C instance. And then as we have used late init in class A and class B, so we need to initialize them over here. Hence I'll write here as class C dot class A is equal to class A object. Similarly for class B as well. And then once it is initialized, then start class C method. And done. This is what manual field injection looks like. It is not tightly coupled, but still there is a lot of code to write. Hence, it is not recommended to use. Next, let's have a look at third case, that is manual constructor injection. I'll comment the previous code. And done. Now in constructor, we usually have parameters assigned. So class C is a constructor, and inside it I'll write private val class A as class A, and then private val class B as class B. Both of them are our constructor parameters. Then we will write start class C function as it is. And done. Now come to main activity. Here I'll call both the classes instance, class A and class B. Then I'll call class C instance as well. But as class C is a constructor, so obviously it will require its parameters as well. So I'll mention here as class A and class B as its parameter. Then simply call start class C method on class C instance. And that's it. This is what a manual constructor injection looks like. Easy, right? But there is something more easy than that, which is Dagger. So now let's move to our fourth case, that is using Dagger. This is very important, so focus. As we are using Dagger, so obviously we will require dependency. So go to Gradle module. Here add both the dependency. I'll mention them in the description box. Also, as we are using kapt, so we will require kapt plugin as well. So inside plugins, mention the kapt plugin. Then next I'll change compile SDK to 34, and that's it. Now click on sync now. And done. Then go to class A. Here we will add inject annotation with a constructor. Remember I said inject can be used with field, constructor and method. So that's why we'll be using here constructor. So wherever we mention inject annotation, it requests for its dependency. Like I have mentioned inject for class A, so it will provide us with class A dependency. Likewise, we will do it for class B as well. Here I'll add inject annotation with a constructor and done. Then go to class C. Here also I'll mention inject annotation with a constructor. As it's a class where all the other classes are dependent, so we do have parameters inside it. Then write start class C function as it is. And that's it. Now listen to me carefully. To use Dagger, we need to create a module object and a component interface that we will access in main. So first let's create module object. Right click on it, new class, name it as class AB module, and choose object. I'll mention module annotation here. Let's have a look at its definition. So module annotation is used on class that construct object and provide dependencies. In our case, it is class A and class B, right? Then inside it, we will create two functions that will return the object. And to do that, we need to mention provide annotation, right? Let's have a look at its definition. It says, provides is used on a method in the module class that will return the object. And that's what we are implementing, right? So I'll mention provides annotation and then create a function called as provide class A by calling class A that will return class A. And that's it. Similarly, I'll do it for class B as well. And done. Our module object class is ready. Next, we need to create component interface. We create component interface for the class on which every other class is dependent on. So in our case, it is class C, right? Right click on it, create a new class. Name it as class C component. And choose interface. Here we will mention component annotation. Let's have a look at its definition. It says component annotation is used on a component interface which acts as a bridge between module and inject. We have already used inject in every class, and also we have already created a module object for those injected class, right? So let's mention it here. Modules as class AB module, and done. Next, inside the interface, create a function as get class C instance. That will call the class C. And that's it. Now our component interface is also ready. Then go to main activity, rebuild the project, and done. Remember in start I mentioned about some factory type class which Dagger uses? I'll show you that. See here, a new directory is created called as Java generated. In this directory, we have all the factory type of classes. Basically, factory classes are used to create instance of objects. All of them are generated by Dagger. Let's have a look at them. You are not supposed to modify or edit it, okay? Now here, write Dagger. See, the component interface will create its own Dagger component. The Dagger prefix followed by a component interface name is a common convention for Dagger generated components. Then dot create method and then dot get class C instance which will obtain the instance of class C, and then dot start class C method which will start its functionality, which in our case including starting class A and class B as well. And that's it. Our code is ready. Now let's run the app. The output will be same only. See, class A, B, C started. That's not even the concern. Our concern is writing code using Dagger. I know Dagger may seem complex at first, but its advantage become more apparent as your project grows and evolves. The benefits of improved code organization, maintainability, and testability often outweigh the initial setup. Like you will be wondering, why is there a need of module object, then component interface and all? It's all extra code. No, they are not. They are all your initial setup so that later your code becomes easy to test and manage. It's like working hard in your 20s to live a stable life in your 30s. Also, I'll be releasing this video in Hindi as well on my second channel, so please do subscribe it. And for more updates, you can follow us on Instagram or join a Telegram group, link in the description box. So yeah, that is it for the video. If you are new to this channel, then please consider subscribing to my channel, and I'll see you in the next video.